Thank you for joining us. Nikolay and I have been collaborating for a while now, but haven't had the chance to even see each other or talk in person. And I was hoping that I'll get to do it while I'm touring the UK. Now we're in the same time zone, so that's nice that we get an opportunity to kind of talk about one of the projects that we've been doing, and for me to hear from Nikolay about his whole perspective about open science and replications and some of the other stuff that he's been doing. I think we've gone through a couple of projects together, one replication, one meta-analysis. I think I was very impressed by how fast you were able to come into a project, figure things out, take the lead, and then revamp everything to making this a whole new level of incredible, and finally ending in at least one publication, hopefully another one, um, in a good journal, and really meeting the highest standards of open science. So this from my side. Learned a lot, happy to collaborate, good output at the end. So a very good journey. Thanks for joining us on these things. So I'll let you take the stage and tell us a little bit about your journey. We'll do a Q&A of whoever is here after the talk. So here's to you, Nikolay.
Yeah, thanks so much, Gilad. I much appreciate that. Obviously, it's kind of a pleasure to speak with you in person as well. I mean, it's been a long journey. It's been quite a bit of time since we kind of started off, and it's been a lot of fun. I think I actually got introduced to you during my master's when I was in Oxford. You gave a talk on open science for the reproducibility. This is the first time I sort of encountered that you work. I think I followed you for a bit. You have a kind of a nice newsletter coming up every so often, and I was like, oh, this is like a fun thing to kind of join as a nice side project. But yeah, it kind of become a little bit more kind of a major side project, and now even more, just because I really appreciate that kind of collaboration, and I think I've learned a lot as well. And yeah, so today, so about me, I am a PhD student in the University of Cambridge. I'm a first year, and my PI is Professor Jason Renfro, who is working very much in personality. And my work is mostly focused, my PhD work at least, is mostly focused on studying personality using large language models. But today I'll present something else. This is kind of one of my kind of other major interests, a lot of open science things, and this is how kind of I got joined in this project. And obviously, kind of studies and effect that's just broadly interesting, and I kind of got into it more and more. The sunk cost fallacy. And so first I'll present the findings from a replication we recently did, a nice paper that ultimately got published. So yeah, so I'll get cracking. There we go. Cool. So a little bit of a background. So the sunk cost effect, well, people tend to, whenever they invest a resource, either time or money in something, they'll try to continue investing. They have a tendency to continue investing, even though it might be a failing course of action, just because they've invested a resource already. So it kind of leads to this escalating commitment and kind of a vicious cycle where even given that you've invested some resource, you continue to invest even more resource. And there was a nice study back in 2001 by Dilip Soman, who whose thesis was that sunk time cost, so whenever you invest time, will be weaker than money costs. And he gave a couple of reasons for that. That we cannot inventory or replace time as easily, so just a little bit trickier than money. Time it's accounted for a little bit differently than money as well, so it's not as easy to aggregate it. It's a bit more funky. And accounting for money is something you do kind of almost on a daily basis whenever you purchase something, or whenever you have to do almost anything in daily life. Whereas for time, this is not necessarily the case. So he posited that there will be a kind of a differential effect between time and money. And previous literature before someone did indeed show quite robust sunk cost effects for money rather than time. And we basically replicated three of his studies. So he had quite a few studies, but we decided on three. And you can see here on the right-hand side, sort of a quick comparison between the two samples, but in essence, he used undergraduate samples, very typical of that time, and kind of still used to this day. That ranges in terms of sample size between 120 to 200-ish. And he very much used undergraduate students. So you can imagine that the age was a little bit lower, it wasn't as representative, and so on and so on. Whereas we used US American empty workers, and our sample size was much, much larger. We also did a bunch of extensions. We didn't just replicate the study. We had some extensions. We had a lot of robustness checks. I mean, a lot of them. Like, we were really confident that we were measuring what we thought we were measuring. So we did a lot of different analyses, a lot of different quality checks to make sure that the data was as expected. I'm not going to touch on these here in this presentation just for the sake of time, but obviously have a read through the paper, maybe even to just skim kind of what we actually did. I think that will give you a good enough idea. And crucially, this was a registered report. So that basically what that means is we write up the introduction, the methods, and we kind of draft the results using dummy data, but we do not collect any data. We submit that to be reviewed by the by a bunch of peers in the community. So it's a kind of a different format where it's more kind of an open source review rather than submitting to a specific journal. And that's how it gets evaluated first by a bunch of reviewers. And once they're happy with our plans on how we plan to execute this project, then we collect data. So it's kind of a different format than your traditional journals. And cool. So we'll go through each study and we'll go through the method and the results for each study in turn, just because it's a little bit easier to follow. So our application of study one, in essence, just compares some time cost and some money cost very directly. So participants were given a vignette and they had to read through a given scenario. And we're not going to go through the whole scenario, but in essence, they had to pick whether they wanted a theater performance ticket or a rock concert ticket. And in one case, in the some time case, which is on the left-hand side, basically they were told how much it would cost them in terms of time. So either 15 hours or 5 hours. More or less, this is what they kind of gathered. In the same money costs, that time was translated to money. So for the 15 hours of work that they would have to do in order to get a specific ticket, they would get $225 US, and likewise for the 5 hours, they would get 75. But here, everything was expressed very much in terms of money. Now, what makes this a sunk costs effect potentially is that the participants are told that in both of these scenarios, they expect to like the rock concert more, even though the theater performance one is the one that costs more. So the theater performance ticket is more expensive, so it costs more time or money, but they will like the rock concert ticket better. And ultimately, in both of those conditions, they'd have to just pick between theater performance or rock concert. Which one do they prefer? And crucially, if they choose the theater performance one, the one that's more expensive, but the one that they will like less, that would give us an indication of a sunk cost effect. So that they would rather go to the one they actually like less because they have invested more resources, either time or money. So this is a really crucial thing. And let's look at the results. So again, choosing the theater performance ticket means more of a sunk cost. So in terms of the original, here's how the results look. As you can see from the x-axis, on the money one, we saw quite a bit of people falling prey to the sunk cost effect. Whereas for the time, this was not the case. And that difference was very significant. This was in the original paper, which was the Soman 2001. When we tried to replicate exactly the same thing, what we found was that there was indeed a difference. People still preferred the money one. So they fell prey to the sunk cost effect in the money condition, not so much in the time one, but the difference was much more, about 40% smaller. So the effect size was 0.38, whereas in the original it was 0.61. So we did indeed find that the sunk time effect was weaker than the sunk money one, much like someone predicted. just because the gray bar here is much lower. So they chose the theater performance much less. In study 2, we kind of extend that analysis, but we add another condition just to kind of see whether the effect holds in a slightly different scenario, slightly different conditions. So again, we're going to be comparing those, but we'll add another condition. And again, we'll have on the left-hand side, we'll have the time condition. On the right-hand side, we'll have the two money conditions. But now that there are two, because we also have one more condition, which is either a condition with sunk costs or no sunk costs. And what I mean by this is, again, people are told that they might have or might not have invested resources. So if they have invested time resources, they're told you have spent 30 hours preparing a specific design. And if they have not invested any resources already, they don't have any information about investing prior resources. And ultimately, they have to decide, participants have to decide whether they want to design a rocket engine or a solar power plant. Basically, two different designs for a competition that they're taking part in. And again, this in the time condition, they have either invested hours or not. And in the money condition, they have either invested money or not. Ultimately, it will take them the same amount of resources, either 10 hours or $30, to finish the design. And they have to decide which one they want to go for. The critical bit here is that if they choose the rocket engine design, the one that they have not, the one that they have invested resources in, that will mean that they fall prey to the sunk cost effect. Because the two are essentially similar, but because they have invested resources before, that will give us an indication of sunk cost effect. And the results for the study, again, we'll look at it this way. So on the left-hand side, we'll see the results from the original, and the right-hand side, we'll see the results from the replication. On the top row, we'll see the money one, the money condition, and on the bottom row, we'll see the time condition. Whereas on the x-axis, we could be comparing sunk cost versus non-sunk cost effects. So for the original, in the money condition, they very much found a significant effect of sunk cost in the money condition. So when there was indeed a sunk cost, people were falling prey to that sunk cost, whereas they did not find out for the time condition. So they were basically the same. Whether there was a sunk cost or not, that didn't make a difference for those people. Because again, if you see more of the black, basically means more of a sunk cost because they chose the rocket engine, the one in which they have already invested resources in. Now, interestingly, in our replication, we did indeed find an effect for the money condition, although it was slightly weaker than the original. But we also find a very strong effect for the time condition. So even in the time condition, when participants were presented with a sunk cost scenario, they did fall prey to that sunk cost effect. They did indeed choose the rocket engine one, the one in which they have already invested resources in. Interestingly, here our effect in the time condition is much stronger than the money condition for our replication. So contrary to the hypothesis that someone put forward, and partially contrary to our results in study 1, now the sunk time cost was not weaker than the sunk money cost, but rather it was actually the opposite, where the sunk time cost was stronger than the sunk money cost. And we had some additional analysis where we kind of compare this a little bit more directly. So this conclusion indeed holds quite nicely, which is very interesting. In study 1, we thought, so we were replicating the Salmon study, and here we try to approach, the approach was slightly from a different angle. So that study was very similar to study 1. So again, it asked the participants to pick between a theater performance ticket and a rock concert ticket. Crucially here, we had two conditions. So the first condition was we manipulated whether the participants were in a high opportunity cost or a low opportunity cost. So either they were told, very similar scenario, either in terms of, so participants were presented this just in terms of hours. So there was no money condition here. So we're focused on different things. So for the time one, in the high opportunity cost condition, they're told that they're badly pressed for time. So their time is of high value here. We really want to emphasize this because there is really high opportunity cost. Whereas in the low opportunity cost, basically they're saying, oh, you have some relative flexibility, you have some time, so you're not as pressed for time. The other critical conditions that we added here, critical condition that we added here, was that we also had a education condition. Basically, this was a vignette that participants saw about how to better account for their time. And that was crucial. This was before they read the actual the second scenario that we're seeing here, but after that they read the first scenario, which was in study 1. So we had a nice comparison there as well. And so that vignette was basically designed to give them a better understanding of how they can account for time. Ultimately, in this case, they didn't just pick between the theater performance ticket and rock concert ticket, but they also did that on a Likert scale, where ranging from rock concert to theater performance, crucially here, higher numbers. So if they pick more towards the right, which you could think about basically between 1 and 9, even though they're labeled slightly differently, the higher number that they pick, the more they are victim to the sunk cost effect. And I'll now show you the results, but before I do that, just it serves to kind of think about what we actually expect to see. So you see on the x-axis there's either the education or the no education condition. On the y-axis, that's the preference rating, so between 1 and 9. And remember, higher numbers means more sunk cost effect. Whereas the color of the lines will indicate whether they're in the high opportunity or the low opportunity cost condition. So the way someone reasoned about this is that if indeed it is the case that time is the reason we do not fall prey to the sunk time effect as easily as the sunk money effect is because time is not as easily inventoried. So basically we can't think about time very effectively. Then if we educate people on how to think about time, how to account for time better, that means that now the sunk time effect will reappear. So the better they get at inventorying time or accounting for time, the more likely it is that they'll fall prey to the sunk time cost effect, because now that they can kind of account for that as well as they can money. So in essence, what this means is that on the one hand, we expect the high opportunity cost condition. So the line that's the black line would be higher than the low opportunity cost condition, because in that case, we expect more sunk cost effect, almost by design, right? Because we kind of try to tell them that they're pressed for time. So we expect the black line to be above the gray line. But in terms of the education condition, we also expect, as people get educated, we expect the line to go up. So we expect higher preference ratings as well. Again, we assume that there is no interaction effect, and spoiler alert, there isn't. And this is what someone found. So he found that when people get educated, they give higher preference ratings. So they prefer the theater performance ticket more, which means that they are more likely to fall prey to the sunk cost effect. And indeed, the high opportunity cost was higher than the low opportunity cost. And both of these main effects were indeed statistically significant. In our replication, interestingly enough, we found none of these effects. Neither was the high opportunity cost condition higher, induced more of a sunk cost effect than the low opportunity cost one, but we also found no effect of education. And this kind of summarizes our findings here. But interestingly enough, we did find mixed support. So in study 1, we did find, as someone hypothesized, that the sunk time cost effect was weaker than the sunk money one, but we did not find the same in study 2, where the sunk money effect was actually weaker, the one that was weaker than the sunk time effect. So that was kind of kind of a puzzling finding. And in study find, we did not find any statistically significant effects at all. And again, we examined this a lot of different conditions, a lot of exploratory analysis, and all of them were in line with these findings. So that was kind of puzzling. So what can we take away? Well, indeed, we did find some money cost effect in all of our studies, right? So in study 2 and study 2 replication, we did find some money cost effects, and that was very much in line with a lot of previous studies. A lot of studies just find this, so we're very much in line with that. But the sync, so this should say sync time costs, but the sync time costs were indeed a lot more volatile and context dependent. So we found them in study 1, but we did not find them in study 2, which is kind of strange. And we, in our paper, we have a few different reasons for the mixed support, and one of them was age. So indeed, someone's original sample was undergrad students, ours was general population. And the reason age is relevant here is that perhaps people have a little bit less time experience accounting for time, especially when they're younger. So as they grow older, they might have a lot more experience, especially as you speak in a job where time becomes a relevant factor and so on. And the other thing is that there are some theoretical speculations, not so many empirical findings, that when we think about sync costs, they're not taken in their absolute values, but rather relative to an individual's total resource. So that means older adults who are wealthier and have less available time that would be essentially their denominator. And so that would change the equation for them. We also speculated that there might be some cultural influences, as society progresses, especially, the original study was conducted in 2001. As society progresses recently, there has been more and more kind of focus on time and productivity. There are a lot of different kind of sub-movements in that area. And so that might have influenced participants in some ways. We don't really speculate which way that effect can go, but we think that this might play some role. And the other thing is that, our study was conducted just after COVID-19, and people might have become even more sensitive to how they spend their time. So that could also play an effect. But again, there's no way to know for certain. Zooming out, I want to take a kind of a breather, just kind of think about actually what I take away from this entire project. And the first thing is that replications can actually be quite tricky, I found. We actually had to adjust a lot of things as we were setting things up. A lot of the original didn't contain enough information for us to be able to effectively replicate that. So basically, we had to ask the original author to basically find the paper copies from 2 decades ago and scan them and send it to us. And we found that there was some inconsistency in terms of how he conducted that study. So we had to adjust a few things. So it really wasn't the case that you basically just take the paper and you are ready to replicate. We had to do a lot of more tinkering, which is kind of funny because, you should be able to, that's one of the main purposes of a nice method section, is to allow other people to be able to replicate your work, not just to kind of get a gist of what you did. Interestingly enough, when we sent the first kind of round for review, we had 5 reviewers on the paper. That was even before we started data collection. So we had 5 reviewers, and ultimately we got 3 rounds of review. Again, that was before we started the data collection, which was very intense. I mean, interestingly enough, the original author, Dilip Soman, was one of the reviewers, and he was extremely positive. We had some other reviewers who were not as positive and very kind of really tried to challenge as much as possible. But that was a lot of reviewers and a lot of rounds of review. That's not very common with traditional journals, which is very, very interesting. Interestingly enough, once we collected the data and we did get the ultimate approval from all of these 5 reviewers, all of these rounds of review, we collected the data, we wrote up the results, and we were invited by the Journal of Experimental Psychology to submit our findings. We did. And they rejected it, which was kind of funny because they invited the submission and they rejected it. Interestingly enough, they additionally sent it to 2 additional reviewers which is not how this tends to work. Usually after you pass your initial evaluation, before you collect the data, that's all the reviews you're going to get. It's very, very unusual to get additional reviewers. And those reviewers, the additional reviewers who reviewed kind of the final manuscript with the data collected, basically said, oh, the results didn't make sense, so the author should conduct more studies and kind of make sense of that. And Gillett ultimately kind of wrote them a rather very strongly worded email asking them to reconsider their decision, and highlighting that basically what they were displaying was kind of an outcome or a publication bias, because they saw the results and they didn't make sense. And so it's the results that define whether the study is going to be published or not, which is very, very weird. I mean, it's the absolute definition of publication bias. Fascinating. And the central concern that all of reviewers had, also the 5 reviewers that were initially reviewing that, was they were sort of questioning the value of replication, which is, kind of a strange argument to raise, because we should be having those replications quite often. I mean, at the end of the day, that was a kind of a rather small study that was published back in 2001. Nobody has replicated it. People just do a bunch of other kind of funny stuff. And I don't think it's quite reasonable to expect that this result from 2001, based on this kind of rather small samples, is going to hold in all contexts for all the decades to come, right? So it's kind of a strange concern to raise, and yeah, I think we dealt with it effectively. But there we go. But that kind of brings me to this kind of observation that I seem to be having in the past months and years as I'm growing my career in academia, is that it feels to me that a lot of these kind of open science practices, registered reports, sharing your data, your code, a lot of them feel a lot more like a requirement rather than a way to think or approach science. And it's become almost like a tick box. Okay, when you submit your paper, you just basically have to tick a few other boxes, and you literally get like a badge of, oh, open data, open, right? So we're all seeing these kind of badges. And so it becomes more kind of a tick box where you just have to check it rather than an actual way you approach science, you approach how you do things. But the thing with that is that if you just try to tick a box, you can still find ways to kind of bend the rules and find ways to really present your findings in positive light. And I'll share with you a few examples, and I really want to highlight that all of these kind of conclusions, all of these thoughts I'm sharing, and a lot of these examples that I'm about to share are just based on my own experience, what I've observed, and what kind of where I am with my thinking, because this is not meant to be kind of a treatise on open science related topics. I mean, there are people who have written much more and have spilled much more ink than me. So these are just based on my own experience. And so the first one I'd like to share with you is that you should always try to study the raw data. It's very easy to hide the raw data behind very, very complicated stuff. And I'll share with you one example. We're not going to go into great depth, but there was basically the study. It is still in preprint stage. I was involved with the group, very cool group. But basically what they found here with this paper was participants had to rate some food items on a scale from 0 to 100. And then in kind of the main task of the experiment, they had to rate 2 items who were positioned next to each other, as you can see bottom right, from minus 100 to 100, essentially. In either they had to rate how much they prefer one over the other, or how much one is larger or smaller than the other, right? So they basically have to give a bunch of ratings. This is all you have to remember from this. We're not going to go in great depth with the study, but basically in the main task of this experiment, participants had a slider which ranged from minus 100 to 100, and they had to rate either how much they prefer that or how big one was over the other. That's all they had to do. This is important. We'll come back to that in a second. And as I said, in a lot of these studies, this is very simple kind of measurements you make, and then folks in this paper created this really complicated analysis. You can see some behavioral results here where you can plot all of these things various ways. They had a lot of different conditions, congruence, magnitude, etc., etc. You can compute a lot of different kind of indices, choice bias, and they did some generative modeling as well, very sophisticated computational stuff. So they did all of this analysis, reached these kind of really cool conclusions, actually. But then when you look at the raw data, what you see is something very interesting. As I said, participants in the main task basically had to rate things from minus 100 to 100. So what happens if you just study that data, right? So if you just look at that and you plot that, where on the x-axis you have the trial number and on the y-axis you have the actual slider rating, you see something kind of funny. You see that some participants give these kind of binarized judgments where they don't really use the whole scale between minus 100 and 100. They basically just use a couple. So they either use kind of 75 and 25 or maybe 0 and 100. So they don't really use that slider. Now, does it make sense to continue with the other behavioral results, the computational modeling? Well, I don't know. But the whole point is that like maybe once you see this, it's like, oh, but does it actually make sense? Now you have to actually make an argument. Does it make sense to continue? Maybe you want to exclude them. Maybe you want to have some thresholds for these kind of participants where you kick them out or you don't include them in the analysis. At the very least, I would expect some sort of robustness analysis where you exclude those extreme cases and you show me that your results hold. Or at least the key results hold with the other participants. But it's very interesting. It's very easy to hide behind that kind of data and do all of these sophisticated modeling on top of it if you have not got proper understanding of your raw data. Another example, this now is much closer to home, much more close to my day-to-day PhD life, is I find that in machine learning. I'm very much kind of the computational social science kind of field, a lot of papers in that kind of area. And with machine learning, it's very easy to, again, hide behind a lot of kind of complexity. And it's a very flexible analysis. You can build these sophisticated models, again, where if you tweak a few parameters, you get incredibly positive results. And it's very high. It's very easy to overfit. I mean, on the right, you can see one example where there's likely some overfitting happening. It's very easy to hide things as well. So be very cautious when you see these things. And this is especially pronounced in a lot of fields where they're not necessarily machine learning oriented, like they're not trying to build new and better algorithms like computer science journals, but it's more kind of not entirely ML focused. So a lot of the computational science papers, especially preprints, you can easily find that where people are hiding their models more or less. So if you see a machine learning paper, they have not shared how they build a model, or even if they shared it, it's very easy to kind of just make it so unreadable that just basically nobody looks at it. So a lot of these, I feel like, are strategies where you try to hide. No, you actually have to display that you've tested and you've trained the model as expected. And some sites, I mean, Kaggle is a popular kind of machine learning website where you can kind of train models and take part in competitions. For example, they allow only one submission per day, which essentially means that you can only run your trained model only once on a validation sample. So you can't really try to overfit it on a validation sample as well. So you have to be really careful with these things. It's very easy to overfit and hide. And the other one is kind of, again, much closer to home. This is with large language models. Because this research is very much in its infancy, it's very finicky. It's very easy to get the conclusion you want or get the results you want, because we do not fully understand how they make these kind of, how these LLMs work, how they give these outputs. So there are a lot of things, a lot of moving parts that we don't understand. We don't have a coherent theory, so we don't know what is expected or not. And so this is just one example where, again, the details of this doesn't matter, but basically they kind of did this really kind of actually really promising and cool simulations. You can see kind of the blue lines are what actually happens in real life that we have observed. And the orange lines are basically what their simulation showed. And this result is true. I mean, this is absolutely groundbreaking work, but the trouble is that this is just way too perfect. I mean, based on my research, like it's very unlikely that we are at the stage where we can simulate things that well. And those authors, not only is that a preprint, but also those authors did not share the code, how they actually achieved this simulation, because they created very sophisticated simulations of entire social networks using large language models. And there are a lot of moving parts. We really don't understand a lot of these parts. And I've shown in my research that even the kind of the starting point of this pipeline is very finicky. It's not very promising right now. Maybe it will be in a couple of years, but not right now. And these guys are showing these kind of extremely promising results. Like it's very unlikely that it's that perfect. So again, very easy to force a specific conclusion and to hide behind layers of abstraction. So that brings me to my original point: is that this kind of a lot of these open science practices indeed becoming more kind of a requirement or a tick box that you have to just check. It doesn't necessarily translate to a more kind of mindset shift. Let's approach this with a lot more care, where we allow other people to replicate our work and build on it, where we try to actually showcase our code. I mean, one of the kind of surprising things is that as I get in touch with more and more professional data science who work in industry, checking each other code is just part of the pipeline, right? So you don't just run some code, like write some code, have maybe ChatGPT review it, and like, oh yeah, this code will work for an eternity. No. You actually have like a bunch of people checking every single thing, writing tests. I mean, try to find unit tests in any research or academia that is not computer science, let's say. I mean, it's impossible. And that's very surprising, right? The fact that there isn't such a shift towards kind of more robust research is, quite telling. And interestingly enough, the moment you try to just kind of achieve the open science practices, like just make sure that you share the code, share the materials, it becomes this kind of vicious cycle. Goodhart's law is a good example. When a measure becomes a target, it ceases to be a good measure. So whenever just sharing your code becomes a target, it's no longer a good measure of the mindset shift. Those practices were designed to steer towards. And there are a lot of reasons for that. Again, a lot of ink has been spilled on that topic. But what I've encountered is that indeed that sometimes there are these kind of really funny incentives that are pervasive throughout different levels of academic life that are making it much more likely that you just kind of treat those practices checkboxes, because they don't really help you push your career that much forward. Maybe in some extreme cases, I can give you such examples where like the research is so robust and so good just because they followed really how research should be done, that that there was some success achieved, let's say, but that's not really the case. Nobody rewards you for failing an experiment after you've been extremely thorough. Maybe if you were a little bit less thorough, but got a little bit more of a promising result, maybe that would have gotten you further. And I can't tell you how many times I've heard this phrase. That's how it's always been done. That's how we've done it, which is kind of a funny phrase. I mean, fair enough. A lot of the times, maybe because you've always done it like that for a reason, but that doesn't mean that from time to time certain things should probably be reevaluated. So that's kind of a funny excuse, but there we go. So yeah, I think I'll end there and kind of turn to kind of a more kind of discussion Q&A kind of aspect.
Appreciate that. It's interesting to hear you reflect a lot. First to hear you display the result and how you interpret them and how you think about them. I remember throughout the journey, even before we had the data, just trying to predict in advance, is this going to replicate or not? I honestly was not sure. And then when the data came in and it was this kind of mixed, I honestly didn't know what to take away from this. And you were discussing about the reviewers in Journal of Experimental Psychology General. I mean, whenever I communicate this or I share this on Twitter, people then ask, so now what? What do we do with this? So I'm curious if you have some, based on your perspective of open science, we have this seminal finding, right? It has a bunch of studies. You conduct a direct/conceptual replication of those. Some things work, some things don't work. Where do we go from there? What do we do now?
Yeah, I think just focusing on this time cost effect. I mean, I guess the way I think about it is often not so much oh, this effect works, this effect doesn't work, but it's kind of more kind of a Bayesian probability, right? So even before I saw the results, just because the findings on the time cost effects were so volatile based on the previous research, my prior for whether this effect would appear was relatively low. Even just looking at the Solomon study, just because it was a one-off study, even before I read the other relevant papers, my priors across the board were just rather low. Because again, that research was not like it wasn't 10,000 participants across 60 countries. Like it wasn't, that kind of level of confirmation. So my priors were already rather low. But as I read more, my priors for the sunk money costs were increasing, right? So because that was an effect that really reproduced quite well. Where the money one, the time one was a little bit more funny. So I couldn't really make sense of it. And our results just kind of confirm that. I mean, my confidence interval is essentially very large. That's one way to put it, right? Um, because I'm really not sure where this is going, but my feeling is that there would just be a lot of different conditions where this would either work or not. And it's essentially just a PhD level work to figure out at least some of the conditions where this might appear consistently or not. Maybe more than one PhD, actually. Just because it's so tricky to figure out exactly when and how it works. And we don't know, crucially, we don't have a coherent theory on where, why, and how it works, right? But bunch of hypotheses, a bunch of effects, but no consistent theory. And I think that's one way to think about it. Let's just try to find a good theory and see if it works.
Right. So I guess open science in general, doing replications and pre-registrations and sharing all of this really teaches me humility about being very cautious about. So you read something seminal, does this really replicate or not? And then adjusting your priors and your confidence intervals about whether this is going to replicate or not. We've done a couple of projects. One is a replication, another is a meta-analysis. Also done is a register report, which is kind of unusual. I'm curious how you see these two, like doing replications and doing meta-analyses. Are they complementary? Do they replace one another? Would they be done together? What's missing if you have both of those? Do you have any views on how the two interplay in open science and gaining more knowledge about the phenomenon?
Yeah, that's very interesting. I mean, I'll be actually very curious. I haven't thought about this question from this angle. I'm very curious what you think, but kind of my gut feeling is that they sort of point in the same direction. Whereas let's just, I guess, to use the terminology that I just used, let's just try to reduce our confidence interval as much as possible. Let's try to make sure that we hone in on exactly what kind of effect we're looking at here. And again, replications just help us do that in a larger scale where we try to verify what has been done in the past. I mean, ours wasn't even that much just verifying that the effect works, but much more let's check if the effect actually exists now. So it was almost like a completely different dimension. Whereas trying to verify that the effect works under slightly different conditions. I'll give you an example, actually. My first study of the PhD, I just got a preprint out, actually, which was basically my colleague from the same lab did a research at Google where he was working on LLMs trying to show whether we can measure their personality in specific ways and whether we can actually shape it in specific ways. And I was like, oh, this is really cool finding. I really want to kind of build on that and build further studies on that. But let's just double check that it actually holds, right? So it actually works. Because he did it with Google's proprietary models. I just wanted to make sure that it actually works before I tried to build on it. And I did that and I was like, oh, this is just going to be a really quick check. I'm going to replicate it very easily with open source models and open AI models. And lo and behold, it became a whole different ballgame where the effect doesn't actually hold. I did some additional analysis, like this does not work as I thought. So it becomes like a whole different project now. So that was more in line with, okay, let's just make sure that it works in slightly different contexts, kind of a more conceptual applications now. Whereas with the Soman, it felt like, okay, we're just checking if the effect actually exists at all. So that's how it sort of worked. In relation to meta-analysis do exactly that sort of thing, where they're more kind of trying to summarize, kind of really hone in on what the effect is, and maybe find some conditions when the effect works and doesn't, depending on the meta-analysis, of course. What are your thoughts on that? I'm very curious. What do you think about how these two kind of relate?
Yeah, I think For me, doing replications and doing meta-analysis is a journey of learning and figuring things out. I was very disappointed with science because doing my PhD, which is already 10 years now, more than 10 years, um, I just expected science to work and for things to be figured out. So if we do replication, we know what a replication looks like. We know how to evaluate a replication. When we do a meta-analysis, we know how to search, code, aggregate, and all of that. But I think in both of our projects, we can see just how fragile science is. It's not easy to do these things. If we think about the meta-analysis, you came in when we were in a bit of a mess because we realized we did a register report, we did a stage one, reviewers went over this, we got an in-principle acceptance, and then looking at the data, we realized there's all these dependencies. It's a nested model. There's all these scales coming from different directions in the IV and the DV. And sorting all of these out, you would expect that, okay, you go through a book or a guide, this is what you should do, and these are the results. But there's just so much flexibility. There's so many packages out there. There's so many skills. And when you ask different people, every time I would post on Twitter, you get 20 people saying different things. So I think to me, it really teaches a lot of humility, but also teaches how messy science is, and that no tool on its own is perfect, and that even all the tools brought together do not give us a complete understanding of what is going on. So meta-analyses are a lot more fragile than I thought they are. They're very, very messy. There's a lot of noise over there. We did the simplest, kind of the simplest meta-analysis possible in terms of coding correlations. When we go into manipulations and interventions, when we go into more complex models, it gets even more difficult over there. The replication, like someone is like the easiest thing. You have a vignette, you manipulate something very, very small, and then you have a choice. Like how it doesn't get much easier than this. But even there, oh my God, the kind of complications that we went through, discussions that we had, challenges that we had to overcome, and then with every reviewer. And this gets me thinking, and I've been posting about this on Twitter and asking people, it's like, if this research, my research, which is the simplest, is so complicated, I don't know how you guys are doing what it is that you're doing. And I think that relates to your general message about just saying I'm doing open science or having a badge is just the beginning of a journey on its own, is just allows you to get a better perspective of just how messy and complex everything is. And we need as many eyes as possible on this to simplify things, to revisit things, So to me, it's just a one challenge after the other. Even after doing all these replications and meta-analysis for over 10 years, trying to do templates and guides and working with different people, I am still learning every time. Every time I work with you, early career researcher, every time I work with an undergraduate and master student, I just realize how little I know and how much more there is to figure out. So I'm not sure what to make of this.
Yeah, that really, really resonates. I mean, so many things to add here, but the flexibility extends even to, so another thing I'm kind of involved in is kind of more psychometric studies. Flexibility there is incredible as well. I mean, there's just so many finicky things that we just haven't quite worked out statistically. That it's just like you really can force a nice conclusion if you have a little bit kind of slightly dodgy data. You can really go either way. I mean, if your data is super robust, it usually, in my experience, it really doesn't matter how you analyze it. It will give you the same conclusion. I mean, one of my favorite tests is the so-called interocular trauma test. I don't know if you've heard of that, but basically, when you plot the results just hit you right between the eyes. It should be so obvious that what the result is. This is the best test, right? Because everything else is just kind of building complexity on top of complexity. My experience with a lot of computational modeling, some of the neuroscience work as well, is kind of matches that. Again, I have very low experience in that kind of a few projects maybe here and there, but I found that there are indeed labs that do a lot of neuroscience work, for example, where you basically have, in order to pre-process some data, you have some script that has been written 10 years ago by the PI when they were in their PhD. And when new students join, how do I like pre-process that data, and you just run that script and that's it. And obviously not all labs do it right that, but it's not uncommon to have that sort of thing, which is really, really fascinating. But yeah, there's a lot of leeway for flexibility.
Yeah, so I'm curious, like moving on, like you're only in the beginning stages of your career, but already you've done a lot of projects. Is there something that you're gonna take away from this or the meta in doing things differently in your own career? How you would like to see yourself doing things in the next, I don't know, 5, 10 years?
One of the things that has kind of been at the peak of my attention recently is that it's very often when you collect these kind of bigger data sets, you have basically the discussion becomes, okay, how many studies we can actually get out of that data set. Or we can kind of slice the data this way, we can slice it that way, which is fair enough. That's fair, because you can't really fit all of your thoughts and hypotheses in one paper. But I really like when you have a single data set, but you have this really big and thorough paper that goes through many, many different things. It's just like, I can think of a few papers, maybe like no more than 10, maybe 5 or 6. I can think of such papers where it's like, it's such a good paper that it just makes my heart sink. I mean, it's just so amazing. They've thought about all these different things. And it's usually, I can think of a few papers where the supplementary is actually better than the main manuscript, just because they've really thought about different analysis, different approaches. And it's incredible, kind of these big papers. And I think in both of those cases, both of the projects that we're working on right now, the replication and the sync cost, it's like, it's so detailed and it's so thorough that it's a pleasure to read from a scientific perspective. Now, from like a consumer perspective, for some like researcher who just wants to figure it out, it's probably a little bit confusing, right? Especially with the replication, it's like mixed support. I guess I see where it comes from, but in terms of robustness, this is how I actually want to carry things. And the study that I just kind of published, the first one in my PhD, is exactly like that, where I try to do as many analyses as possible. A lot of them just got relegated to supplementary, that sort of thing. But I just try to look at the data from so many different perspectives, so many different angles, different analyses, and different approaches that I just try to make sure that it's as robust of a conclusion as it is. And I think this is what we're doing in both our projects. And this is what I like about both of these projects. This kind of rigorous, thorough work, even if it doesn't bring the best conclusions. I love that. And I think this is one of the big takeaways for me.
Yes, interesting. I'm curious because your field is very different from mine, so I don't actually understand much of the LLM, the machine learning related stuff. But I'm curious, given that you went with us, you went through a register report, the whole process from beginning to an end. And then in the meta, you joined in a stage 2 of a meta-analysis register report. I'm curious, like, what you think of register reports and how they apply to your field. Is there a way of making them work or work even better in a way that would really add value and make the science better in your subdomain?
Interesting. With LLM research specifically, very tricky, because we have no idea what's going on. People are just throwing preprints right and left and right. And I've been given such advice again from a little bit more senior people than me in that sort of area, where it's like your task is basically just churn out, like if you have a good idea, execute that idea as quickly as you can, because it's really like people are publishing as they go. I mean, this is like not even 2 years of research, especially in the computational/social science work. That area is very in its infancy. So you really want to make sure that you get the preprint out, because preprints are actually, I mean, 70% of what I read day to day is preprints. So there's a lot of dodgy work there. So you have to filter them out carefully, but it's all preprints. So it's very hard to get a registered report to work, because we don't know what will work and what not. We're basically just throwing things at the wall and see what sticks. And that's fine. When you kind of begin something, that's fine. I mean, I also do, I'll give you an example. So I also do kind of another side interest of mine is doing some work to forecasting. So how good are people actually forecasting different things, policies, prices, etc. And there, for example, we do pre-register a lot of the things. Um, we haven't integrated something like a registered report, and I'm not sure why, because we have a lot of the different things actually kind of figured out. I guess a lot of our analyses are exploratory because we're collecting really huge data sets. But still, for example, we did pre-register our main studies. We had nice pilots. We kind of built into it. We developed the paradigm, and we did pre-register the main study that we just finished data collection for. And now we're pre-registering more studies that we basically, we kind of have the data now, but we're going to explore it. And then once we feel like we got a good grasp, now we just actually build proper hypotheses and test them in even more samples, even more tests and so on, right? So this is how we can probably make that work. But we're definitely, so in my work at least, I've tried to kind of implement a lot of these practices as well. And just it's really about the approach to data. So for example, I think most, if not all, of my projects have data and code shared, and in what I consider to be actually really solid format. So with the Soman, I think we definitely have really nice code where you can actually go, you can see exactly what's happening. You have a code book, you have a description of the different variables and so on. So I try to take as great care as possible to make sure that this is accessible to other people, and they can easily replicate what I've done.
Great. I think it's time for us to wrap up. So thank you very much. I really appreciate it. We have a few other projects we need to work on, so I'm looking forward to that. And maybe when we wrap those up, we can revisit this and do another one of those. Hopefully someday meet in person. Any last words, things that you want to say?
I'm just happy to be here. I'm happy to be chatting with you. I mean, it's obviously a pleasure. I mean, we've collaborated for a bit, and we've had our kind of back and forth, a lot of kind of discussions, and I've learned a lot from these projects and working with you. So I very much appreciate this opportunity as well.